Okay, so here we have a question which continues on from the previous question. We're told the time of flight is measured to be 3.52 plus or minus 0.02 seconds. So we've already dealt with this question. Calculate the initial velocity in y and find the uncertainty. So the focus of our question now is finding the uncertainty in the initial velocity in y. Now down here we have the two initial velocities. One of these corresponded to a maximum, one of them corresponded to a minimum. So now we need to work out what the uncertainty is in terms of possible initial velocities. So the way we're going to do this is we're going to find what happens when the time of flight is equal to 3.52. Because what we did was we found that what happened when the time of flight was 3.54 and 3.5. But if we find the initial velocity at 3.52, the bigger difference of the two between the initial velocity at 3.52 and the maximum here and the minimum here will give us the maximum possible difference. This divided by the initial velocity at a time of flight of 3.52 will give us the biggest possible uncertainty. So this is a very technical experimental way in order to calculate uncertainties. So we know that time of flight is equal to the initial velocity in y divided by 4.9. So this means the initial velocity in y is equal to 3.52 times 4.9. So 3.52 times 4.9. This gives us 2,156 over 125. 2,156 over 125. Now all we need to do is find the percentage differences between this initial velocity in y and these two initial velocities in y. So first we'll do it for the max. So the percentage difference, which we'll call percentage change, is going to be equal to this value minus this value divided by this value. So we're going to have 8,673 over 500 minus 2,156 over 125 divided by 2,156 over 125. And then we're going to decimally approximate this. So this is a rather large expression to have to put into the calculator. You have to be, if you're using a calculator to numerically simplify these, you have to be very careful to actually put the right numbers in and to put brackets around your fraction numbers, otherwise the calculator may mess up the order. Over 125, this is divided by 2,156 over 125. This gives me 1 on 176. So this is 1 on 176, which if we convert to a decimal is about 0.056, 0.000568. So this is a relatively small error. Remembering this is essentially a percentage error because we've done it. It as a decimal, but we've done it as a percentage error calculation in the sense that we've adjusted it for the initial fraction. Now we need to do this for the min. So we did it for the max, now we'll do it for the min. So the percentage change is equal to, if we wanted this first one as a percentage actually, we would have to multiply it by 100. So we would get a 0.0568% approximately. Once you've got this number, the conversions are trivial. So the focus is really on getting this number, not so much on converting it. Now we have to do the same thing, but the minimum number is 343 on 20. So this is 343 on 20 minus 2,156 over 125 divided by 2156 over 125. So this gives me, you can use the same calculator template pretty much. You're just going to be changing the numbers in the first bracket. So here we'll have on the denominator we have a 20. In the numerator we have 343. So this gives me minus 1 on 176. So this is exactly the same, about 0.568%. And so therefore when it says find the uncertainty in this case is actually equal to 0.568%. And this is rounded to 3 decimal places. You could do this in a longer form if you want, but this is pretty much good enough for almost all calculations. This is how far either one of the initial velocities could be from the expected initial velocity. So this is the answer that we're after here, and this is one way to go about this question.